So over the course of the next couple days, I'm going to give you 6 different interest formulas, 3 each day. When it gets to the quiz, I'm going to give you a formula bank, right? You know, like how you have word banks on like your Spanish test, and sometimes on your history test, you'll have a word bank. So I'm going to give you a formula bank, which means all the formulas will be there, but I'm not going to tell you which one's which or which one to use. So you could choose from your formula bank. That means you don't have to memorize these 6 formulas, but you just need to know how to use them. Okay? So we'll do 3 today, and we'll do 3 tomorrow. So what you should do if you're organizing your notes, we're going to do 3 types. And the first type is called simple, and then maybe skip like 2 or 3 lines, 2 lines maybe. And the next one is called compound. And then skip a couple lines, and the last one is called continuous. Okay, simple, compound, and continuous. Those are the 3 kinds we're going to learn today. And so what you need to understand is what each of these mean. I'm going to give you an explanation of each of these types of interest. Simple interest is only paid once a year. An example of this is something called a property tax. When you buy your first home, you are charged a property tax that is owed to the state, and they collect it on November 30 every year. Okay, once a year. Smart of them to collect it right before Christmas, before you blow all your money spending at Christmas time. But once a year, your $6,000 property tax, or whatever it is, to the state will be due. So you got to plan ahead of time, knowing that that bill is going to come at the in the month of November. So, because most people don't just have $6,000 just lying around, so they plan, set us a little bit aside every month. Now, depending on where you live, your property tax and how large your home is, and the city that you're in, your property tax will be different. But that's an example. It's paid once per year. That's called simple. Okay. Compound interest. That is paid several times a year. Now, several times can vary. It could be once a month, which would be 12 times over the year. It could be quarterly, which is 4 times a year. And it could be every week. It's just the person charging you interest has determined how often they're going to do it. It's not just once, but it's kind of spread out. The last one is called continuous. This is the worst kind of interest possible, okay, because it's ongoing gradual interest. What that means is every millisecond of every moment you are sitting there, you are being charged interest. Okay, there is not a moment of the day of where you're not being charged interest. So every millisecond of every second of every minute of every hour of every day of every week of every month of the entire year, you are being charged interest. I would hope that if you didn't learn anything other than don't ever get suckered into something that is continual interest. All right, it is terrible for you. All right, so there are 3 formulas for these. Like I said, you won't have to memorize these formulas. You just need to know which is which. All right, here we go. All of the formulas start looking the same. A equals P, A equals P parentheses. There's going to be parentheses. A equals P parentheses. They all start out like that. A is called the amount that you end up with. P is called the principal. Now this is a different spelling of the word principal than like Mr. Stahl. Okay, this is principal, which is that letter P, and it's the same all the way through. Those are all the principal. Principal means the beginning amount of your money, okay, how much you start with. So that would be the same. Okay, you start with $1,000 or start with $5 or whatever. That's called the principal. Okay, the first one, the simple. The formula for that is the simplest formula. It's 1 plus. In fact, a couple of them are 1 plus. The simple one is 1 plus RT, and that's it. That's all there is to it. R stands for the interest rate. It is a percentage, so it's the rate of interest that you're being charged. T is time in years. The compound is also 1 plus R, but R is divided by K. K is how many times per year this is going to happen. So if it's quarterly, then it would be, K would be 4. If it's monthly, K would be 12. If it's weekly, K would be 52. So you have to have a little bit of a knowledge of how many days and weeks and months are in a year. After the parentheses, K shows up again in the power, and so does the time. So KT is part of the power. So K is actually twice, and that is when you are paid on an incremental basis. And then ongoing interest. This is the only one that uses the number E. And that's all that's in parentheses is the number E. And then RT is the power. You may know this formula from a previous math class called the PERT formula. P-E-R-T are the letters. So some people say, hey, use PERT. Okay, but this is the ongoing, continual, gradual interest paid all the time. All right, so those will be 3 that are in your formula bank. And so let's practice how to decide which one we're going to use in which situation. So here's your first example. Starting with 3,000. So that'll be your principal. So that'll go in for P into whichever equation we decide to use. So starting with 3,000, yeah. The word continuously trumps compounding. Yep. The continuously is the word that you look for. Yep, the distinguishing word. Because it'll say compounded monthly, compounded daily, compounded continuously. As soon as you see the word continuously, you switch to the E. Mm-hmm. Okay. Starting with that, how long will it take to double your money while earning interest compounded monthly at 5.25%. All right. Starting with that given amount, how long will it take to double your money while earning interest compounded monthly at 5.25%? Okay, Hayden, is there a word in there that clues you into which of the 3 formulas you want to choose from? Okay, kind of a giveaway, right? All right, so we're going for compounded. So that compounded means I'm choosing the compound formula, which is A equals P parentheses 1 plus R over K to the KT. Okay, Trav, can you pick a variable and tell me what number to put there? And I don't care which variable you want to pick.
3,000.
4.
Is it P?
Okay, 3,000 is for P. All right, so he claimed the number 3,000. We're going to put that in for P. All right, Kaden, pick another variable and tell me what to put there from the ones that are left. Okay, and where would I put 12? Yeah, okay, so he's picking the word monthly. Okay, great. And where would I put that? Okay, now T is always going to be measured in years, and so I'm not going to put monthly in for 12 and for T, because that's not a years. Okay, 12, like that flee, that monthly, like daily, monthly, that tells you how often the interval is happening. And so that's that K number. So you're exactly right, Alina. We're going to put, so Caden picked out the number 12, and that actually shows up twice. It shows up in K is the position of the fraction, and K is the position of the power. All right, Rachel, pick something else to plug in. And where is that going to go? The rate, and so how do I put that in? Because it should be a decimal, remember I said. How do you change 1/4 into a decimal? Okay, so what would that be? Okay, and so then how do I do that with the 5? Okay, so we've got a 0.05 for the 5, but we also have the quarter. So how can we put all that together? Any ideas? Yeah. Not 1 point. Just, I don't know if, did you say 1 point or did you say O point? It should be O. Okay, 0.05, that's the 5%, and then 25 is the quarter. Because it starts out as 5.25. 5 1/4 is 5.25. That decimal then would move. All right, so now we've got that. All right, we need one more. We've not quite got this thing all the way filled in. Any other ideas? I won't pick on anybody. Okay, Devin, you want to volunteer? Okay, awesome. So he's picking up on the word double. Okay, the word double is a clue already. That means you have to end up with double what you started with. And if we started with 3,000, we should end up with double that, which he says is 6,000, which is going to go over here. Okay, so the 6,000 is what we end up with, which means the only thing we don't know anything about is how long, how many years it will take. So t is our unknown variable. And you should be left with one variable, and that's it. So now once we get this set up, now we want to do legal math to both sides to work on getting our t by itself so that we can solve. All right, so Jared, get me started.
Divide 6,000 by 3,000.
All right, we're going to divide both sides by 3,000. So we're working towards getting t alone. 6,000 divided by 3,000 is, of course, 2. And so then we've got the parentheses, 1 plus 0.0525 over 12. Okay, please don't turn 0.0525 over 12 into a decimal, because you want to keep it as a fraction. Fractions are more accurate than decimals, so don't use your calculator to try and figure that out. Just leave it the way it is, and you will get a more accurate answer. All right, we're still trying to work on getting t alone. So my first legal move was to do the 3,000. What's next? Okay, Devin, yeah. Right, I can't subtract 1 because it's in those parentheses. There's something else I need to do. I'm trying to get t alone. Michael?
Log.
Okay, what kind of a log? Okay, I want to use an ln. My ln is so that I can take my t, which is up by the 12, and I want to pull it where? To the front. Okay, so that's the whole point, is now we will use an ln in front of both sides, which will pull the 12t to the front of the ln 1 plus 0.0525 over 12. It's exactly what I want to do. Okay, pull that all the way over. Now that I've pulled 12t to the front, I still want to do some legal math on both sides to help me get my t by itself. So Christine, what could I do next to get my t, work towards getting that t alone? All right, so divide the big ln's, yeah? Okay, so ln2 divided by the other ln, and just, again, trust me, keep your parentheses and keep your fraction. That gives me 12t, so I'm close to having t alone, and I just need one final step, which is what, Derek? Yeah, so divide the whole thing by 12. And really, it's okay. You've got your calculator to do the hard work. So ln 2 divided by ln 1 plus 0.0525 over 12. And then divide all of that by 12. All right, grab your calculator, which is what you needed it for now. And using your parentheses correctly, go ahead and type that value in, and I'll let you know if you came up with the right answer or not. Okay, Katie, you got an answer?
Katie, I'm sorry. Yeah, I thought that.
Okay, 3 decimals, so keep going.
Oh, one. So 13.232.
But what comes after the 1?
Six,
So, okay, so 13.232, and what should the units be on that? Should be years because this is time. All right, so then if I ask you, what does that mean in the context of this question? All right, so the context of the question is we're trying to double our money. Go ahead. Okay, it would take 13.232 years to double your money, and that's exactly right. Okay, so you have to be patient. So if you're, that's why you parents should make investments for their kids in like preschool and kindergarten, because it takes 13 years to double that investment. So hopefully by the time they go to college, now their amount they invested in has increased. Okay, all right, let's try another one. You might want to ask your parents, do you have any investments? Did you make an investment for me? Start talking with them about college and if they made a plan. Okay, here's another one. How long will it take to triple your money compounded continuously at 3 1/8%. So this is a similar question, but we're actually going to use a different formula. And there's, again, you got to kind of read between the lines and get the clue words out of here. What's going to help you pick the right formula? All right, so Angie, if you were to pick now from our formula bank that we've got so far, what do you think? Yeah. Okay, even though it has the word compounded and the word continuously, it's the word continuously that is the one we want to focus on. And so this is going to be the PERT question. So A equals P parentheses E to the RT. Now there's only one number actually in this question. The only number in the problem is 3 1/8. And so let's practice turning 3 1/8 into the right kind of decimal. So 3 1/8 is 3.125. That's what 3 1/8 is. If you take 1 and you divide it by 8, you get 0.125. So if we want to make that a percent, this is what Rachel was working on before. If you want to make that a percent, you move the decimal 2 places over. And so that means when we go to our question, our R is 0.03125. Now that was the only actual number in the problem. But there's still more information in the problem that can help me do more. Okay, what else is a clue in the problem? What else have I not tackled? Yeah, Derek. The fact that I'm supposed to triple. So what do I do with that if I want it? Last time we knew we had to double, so we could double the $3,000 that was given there. This time I don't have a dollar amount. What do I do? Okay, so I don't know how much I'm starting with. I'm starting with P. It's an unknown amount. But can I triple P? Sure, it's just called 3P. All right, they're not trying to make it super hard on you. They just want you to, if you don't know how much to go in for P, at least you can put in 3P. And so we will have 3P on one side and regular P on the other, and 0.03125. And that is enough for me to be able to do legal math on both sides and get started. Okay, so Aviana, how do I get started there? Sure, Sure. P is a letter, and I'm allowed to divide by that. So I'm going to divide by that P variable on both sides, which means I'm left with parentheses E, point to the 03125T. And then, Aviana, what are you left with when you are on the 3P divided by P side? Just 3. Yeah, the P's reduce away, and you're left with just 3. Now we're going to do a natural log, which is similar on both sides. So we're going to take the natural log and apply it on the side with the 3, and I'm going to take the natural log and apply it to the natural log side, which allows me to pull the power out to the very front. 0.03125T goes in front of now the ln of E, which is, yeah, because ln and E cancel each other out. And so all I'm left with is 0.03125T because the ln and E reduced each other away. So my only final move is to divide by that decimal, 0.03125. 0.03125. All right, so now's your chance. Notice I really don't use my calculator very much. I really only use it at the very end when I'm ready to type that in. Okay, so go ahead and type that value into your calculator. And let's see what we get for that. Does anybody have an answer for that? Okay, 3 point, say it again. 516, and what's the units on that? So it's years. All right, so it would take 3.516 years to triple your money. Regardless of whether you started with $5 or $5,000, it'll still take that amount of time to triple it.
35.
Oh, 35, sorry. Did I put the decimal in the wrong place? Or maybe you didn't divide by the right decimal. Maybe we both made a combination of mistakes. 35.1. Then what comes after? I need another decimal. 16. Oh, 156. All right. Okay, last one. What's the better option? All right, so I'm going to give you 2 scenarios. $1,000 at 5% simple interest, or $1,000 at 4.9% semi-annual interest. All right, so those are your 2 situations. So you have 2 different formulas. Of course, the word simple tells you which one to do for simple. With semi-annual, you're going to use a different one. So the simple, of course, would be A equals P parentheses 1 plus RT. The semi-annual is a repeated amount of time. And so for the semi-annual, you'll use A equals P parentheses 1 over R to the K, KT. So both of them are going to start with $1,000. So let's get that going for both of them. And one of them has a higher interest rate. Okay, $1,000 for both of them. 1 plus, 1 plus. The simple interest is 5%. So 0.05 for the R. And we're just going to assume we're going to do 1 year for both of them. It would not matter if you're comparing the 2. It doesn't matter what time you pick as long as you do the same time for both of them. You could do 10 years, you could do 100 years. As long as you pick the same time, you can compare the two. All right, for the semi-annual, we're doing 4.9. That's 0.049 divided by, now I need a K. Semi-annual means how often, you Nordstrom shopping people? Okay, twice a year. Semi-annually means twice a year. Once in June, once in December, or whatever. Twice semi means twice. Okay, and so 2 would be what I would use, and 2 again, but 1 for the time. All right, so here's where you want to just grab your calculator and type it in and compare which one ends up with the higher amount. Is it the 5% with the higher percentage, or is it the 4.9 compounded twice? All right, does anybody have the simple answer? Okay, 1050. All right, does anybody have the semi-annual one? 1049 point? I got 0.60 is what I got. Anybody else? Okay, yeah. This one? Okay, so which one is better in this case? The simple, barely, right, by 40 cents. Not much better, but barely. Okay, the longer you go, okay, you'll see that maybe one becomes better than the other the longer you go. Okay, eventually the semi-annual will take over the simple and it will be better. If you went to 5 years, it would be the opposite. That semi-annual would be the better option.